I'm Ash. I'm at Zetta, and many of you may have met me. We have here Anthony, and I've had the pleasure of knowing Anthony for a decade, and maybe just a tad more. And we got to know each other when he was first starting Kaggle, and then he went off to really take that from a project that he was working on in Australia and over here, and then grew it quite significantly. And we serendipitously were able to start working together in a more formal way about 5 years ago. So, what we're going to go through today, um, I'll admit up front, is sort of angled towards something, which is what do we really need for data scientists and machine learning engineers today? Um, what do they have available to them that's great, and what would they like to have available to them? And the reason we're going with that angle today is because Anthony runs the biggest community of data scientists and machine learning engineers on the planet, by a long way. So, Anth, I'll start by opening it up and sort of asking you to think back to when you were um, a data scientist yourself for the Reserve Bank of Australia and whatever else, and you still do data science today yourself. Like when you were starting as a data scientist compared to today, and when I say data scientist, I mean someone working on an experiment or trying to learn something by themselves using more statistical methods rather than necessarily more complicated machine learning methods. What's changed in all those years for that type of individual contributor work?
First of all, I was using MATLAB initially. That's changed.
Yep.
Maybe to anchor with where I started my career. So
Yeah.
I studied econometrics and statistics. So that was my background. But through university or college, I had a job as a programmer, and I like the definition that a data scientist is somebody who knows more statistics than the average programmer and more programming than the average statistician. And so when my first job out of college was at the Australian Treasury and then the Reserve Bank of Australia, doing econometric modeling. So it's data science-ish, I guess, is the way I would put it. In that you typically have like some theoretically driven model based on theory, and then you fit parameters to that model, and that's how most econometric modeling is done. So you can think of them as parametric models. Where you assume a functional form. And certainly at the time, MATLAB was probably the main thing people were using. And I actually remember having a coworker in the cubicle next to me who used to read Slashdot and was trying to get our stuff running on Python at the Reserve Bank. And I thought, this guy is nutty. He ended up joining Kaggle and was a co-worker for a long time, but that was sort of the first I had seen of Python. When Kaggle first launched, people were, I would say it was MATLAB and R were and maybe a little bit of SAS were the dominant things, and Python really started to rise. Probably, I'm trying to remember when it happened. I mean, the random forest was dominating Kaggle early on, and R had a really nice implementation of random forest. And I do not remember when random forest, and there was a nice implementation for Python. But I think to give you an interesting fact, we launched our hosted notebook product. You'll remember this, Ash. It was around when we started working together in 2015, and we started by having it be we made it R before we supported R. That was the first language. Like, it really wasn't clear whether you should support R or Python. And the other interesting fact is it wasn't actually a hosted notebook, but it was a text box with a run button. Yep. And so two things started really happening since 2015. One is the switch from R to Python really became very clear. And the second piece is that Jupyter became by far the dominant quote-unquote IDE. Jupyter Notebooks became by far the dominant IDE or whatever you want to call it, environment for doing data science. And so that's kind of where we are. It started with MATLAB in their commercial IDE, then I went to R, a bit of RStudio, a bit of Revolution R, and now it really is at least Kaggle. It's Python and Jupyter notebooks are the thing that are really really dominant.
And what about for your sort of workflow? So that's what you're using, whatever else. What used to trip you up that hasn't changed, that still trips you up? And what used to trip you up that has just been abstracted away and been made so much easier?
I think one challenge in answering that question is I feel like over the years I used pandas more and more and more, and some of the been using the same libraries for a long time, and so I've become very familiar with them. So it may be hard to give you a really clean answer to that because partly the tools have changed, but partly my skills have changed as well. It's probably, one big thing that has changed from a tooling perspective or from an infrastructure perspective is we went from mostly training on CPUs to GPUs, and that I probably don't need to talk too much about what that has done, but that has been a big one. And maybe the change that is underway at the moment is, if we it went from CPUs to GPUs, the thing that is getting much, much easier to do now is going from training on a single GPU to training on, much larger clusters. And there's a bunch, TF2 has made a lot of progress, for instance. TensorFlow 2.0 has made it much, much easier to train across multiple chips. So that's probably the something that has is really changed of late.
Okay, so what we're going to do now is we're going to go into three different areas sort of in this theme, and then we'll jump to two sort of bigger picture things. So we'll talk about development, data sets, and deployment, and then we'll go into what's going on at Google, which is where you are and where you run a lot of products, and your experience running a startup. So just sort of to continue on from what we were saying and to go into a little bit more detail into one element of it, I want to ask you about, the core thing that a data scientist use, which is the notebook. And for those on the line who are not necessarily familiar with this, think of it as just like a place where you edit text, where you write code, but is connected to other things. So, might let you then, it has other features. So it might help you autocorrect things. It might have lots of little shortcuts, and then it might connect to something else. So it might connect to a version that another one of your colleagues has or something like that. So anyway, that's just a little bit of a background. But yeah, just think of it like, the data scientist version of Google Docs. And I was wondering, what you think is going to happen to the notebook, because, on the one hand, we've got a very dominant, very good sort of set of open source options. And on the other hand, we still see a lot of companies trying to build a better one. And so on the one hand, you've got data scientists doing work by themselves, and they'll just choose the best tool for the job. On the other hand, you've got a whole bunch of people that want to work together. So you've got individuals, and then you've got groups. You've got people doing stuff that doesn't require a lot of computing power. You've got people doing stuff that does. You've got people using simple methods, complicated methods. And then you've got open source versions and other versions. And so there are a lot of options for a data scientist. And where do you think this is all going to go?
Yeah, I'd say we're in the process of seeing one fairly obvious change at the moment, which is going from everybody pretty much using notebooks on their local machine to now there are a lot of hosted, there's quite a lot of hosted notebook products, and they're doing really well. So one obviously I know about is in great depth is Kaggle notebooks. So we have a hosted notebook product. Also at Google, there's another product doing exceptionally well called Colab, and so that is like a very obvious. A very obvious change. It has nice, hosted notebook has nice features from a collaboration perspective and versioning your work such that others can pick it up and extend it. And there's a whole lot of advantages. I would say the shift that is most likely after that, well, there are two shifts that I think are likely to come next. One is if you look at the the two notebooks, the two hosted notebooks leading the market, Kaggle notebooks and Colab. Both of them are really not enterprise grade notebooks, right? In Kaggle notebooks case, it's really oriented towards public sharing. In Colab's case, I think they think of it as a scratch pad, right? A place where you go to play around, and they have a lot, some really nice production work, more production grade workloads as well, particularly
More
inside Google. Yeah. And so the next, one of the next big things is having something that is really an enterprise grade notebook with granular permissions and LDAP integration and things like that. That's a sort of a fairly obvious next step and a fairly active place where a bunch of startups are playing. So you've got companies like Hex, which I'm an investor in, is going in that direction. Then you also have, sorry, my screen just went to sleep. You also have maybe some forks, reimagining the notebook and making it easy to build apps out of a notebook. And a nice example of this is a company called Streamlit, which is sort of taken some of the things that work well about the notebook, looking at some of the limitations of notebooks and building an alternative to the notebook. And that's another potentially exciting direction. And then I think the third direction that's exciting is making it easier to run really scalable, large-scale jobs. One exciting thing that is certainly in the air is this idea where you run a notebook, and underneath the notebook is compute that is a bit more elastic than what you get at the moment. So that's another exciting direction that a lot of people that there's a fair bit of activity around. So those are kind of three variations. It's impossible to know exactly what's coming next, but these are three active areas that I think are all exciting for different reasons.
Well, yeah, and you've made a very good, strong statement there, which is that nothing available is really enterprise grade. And just to sort of also bring two things: one, that is a really interesting, strong statement, and two, just to bring some other people back in who may not be sort of working with these products every day. The way I think about it, or the way I'm thinking about it as we have this conversation, is just like for most of us, going from Word to Google Docs is one thing. Going from Google Docs that plugs in through Zapier or through using a different tool like Airtable or whatever else, to sort of having a little app built on a Google spreadsheet, or having a little thing, a form that fills in a Google Sheet or whatever else, that's another step. And so, in the data science world, you've gone from working with something that's just the text file on your machine to working with something that's hosted on the cloud and is backed up, and maybe you can share it with someone really easily, to having it pipe straight into a massive computer running it as an application. And so that sort of leads to what we were going to talk about next, which was deployment. And so again, for those who sort of don't know what I mean by that, deployment is, okay, so you built a model, what happens with it? How do you serve it to someone? So you built something that makes a prediction about something. How do you get it out there? And there are so many options. You can just ask them what they want to predict and print a report. You can turn it into an Excel sheet, or you can put an application on top of it. And obviously it gets very complicated when you think about something like serving a prediction of the next ride in an Uber application. There's 30 steps that happen between the thing that the data scientist built running and the user getting the car. Of all those different options of how to get a model into the world, from printing a report all the way through to having a very complicated application built on top of it, of most of the work that data scientists and machine learning engineers today are doing, how is it being seen and used? I mean, of course, a lot of it goes straight into the trash bin. It's an experiment, didn't work. All right, let's try another one. But how are models really being put out there for the most part in the real world?
Yeah, I would say historically, think it's Josh Wills who breaks the world up into type 1 and type 2 data science, where type 1, the output is, as you say, a report or some sort of batch, scoring, and the other is batch inference. The other is in real time, like serving up a recommendation for what movie you want to watch on Netflix or what Amazon product you want to buy. Um, um, certainly a fair bit easier. A data scientist working in prototype mode can easily generate their own report. For the type 1 use case. For the type 2 use case, getting a model into production, it's really tough. It's one of the seams. You have a bunch of difficult seams. The seam between UX design and front end engineering is a difficult seam, and that handoff is not easy. And right now, the handoff between a data scientist, prototyping and getting something into a production system is hard. There's a few things that make it hard. So very often, a data scientist experimenting doesn't really care too much about latency, but if a model is going into production, there's a good chance it needs to have some low number of milliseconds in terms of latency, and so somebody putting in an algorithm into production needs to optimize it for performance. The second issue is very often a model will take inputs known as features, and we'll turn those features, we'll run those features through the algorithm and spit out a prediction. Now it's fairly easy. Data scientists can go into a data warehouse, select the features they want to use, but then when it comes to productionizing the model, you have to have like a stream of those features going into, you have to have a productionized version of those features. In each of these cases, there's quite a few different approaches that are being taken to solving those problems. One pretty trendy way of making it easy to get features into a production system is using a technology called a feature store. There's a few, you see there's some ex-Uber people started a company called Tecton, which has raised a large round from Andreessen Horowitz, focused on this idea of the feature store. And the idea is that these are already pre-built. If you have features that are already ready to be plucked off the shelf, they're already quote unquote productionized features, right? And so a data scientist who's prototyping, as long as they restrict themselves to that list of features, there's already a productionized version in the feature store. For the deploying models, obviously I'm most familiar with the what we're doing at Google Cloud. We have these deep learning virtual machines, and then the idea is that, so let's say you use a notebook, for instance, using one of the already set up virtual machines. They're set up to play well with Google Cloud's prediction service, and so the idea there is that you prototype, you get your model working. As long as you don't change the libraries on that virtual machine, it should productionize decently well. With obviously that depends on exactly what was done and what the model involves, but the idea is to make it quite easy to go from prototyping to production. And then similarly, Google Cloud has a bunch of different ways to train a model. You can use the raw VM, you can use the managed training service, you can use AutoML. In each of those cases, there's a nice path into an inference engine that should give pretty good performing inference. So not that these are all, the feature store is something that's becoming popular, and these prediction style and these smooth path to a prediction endpoints, the products are still being developed and still maturing, but you can definitely see the direction of travel here. And pulling back, I think you look at where software engineering was 15 years ago. It was a lot less fun to be a software engineer 15 years ago than it is today. I feel like data scientists in 15 years' time are going to look back at what we have to do today and think, oh, that looks awful. So a lot of the companies that are being built now and the technologies being built now will make this a much more pleasant profession going forward.
Yeah, and I was going to dig in to that end on just one thing you said, which is really, as we see it, like right on the cutting edges, and we're just seeing some companies build some really cool stuff here. You mentioned Tecton, and there are a few others, and how it parallels with what's happened in software engineering. So the thing I'm referring to is this idea of a feature store. So, to just sort of provide a bit more background for those on the call, a feature of a model in machine learning is something that is predictive of something. It's like one of the things that sort of generates the prediction. Just like a feature of the product is one of the things that, performs some function. You click a button, it calculates something, and it spits it out to you. You click a button, it runs many, many, many calculations, and you're able to check out a cart of stuff that you've bought on a clothing website. And in the software engineering world, the big thing over the last 10 years now, even more, 10, 15 years, is this idea of having Lego blocks, whether it's, having lots of reusable code internally, but more so having APIs that you can access. So the example I just gave of checking out of a store, previously you had to just write all of that software yourself, all the little steps to check various things and make sure the credit card was correct and run it and talk to the bank and blah, blah, blah. You have to do it yourself. Now you just call a Stripe API or another company, Magento or whatever, another API. And this is sort of just beginning to happening in data science and machine learning, it seems, where you can start picking and choosing features that people in your own organization have written for a different model. They wrote them to put into one model to make one sort of prediction, and you can pull them off the shelf, so to speak, and put it in to your model for the next thing you want to work on predicting. And then you see it at the big companies with, these pre-built or pre-trained models, and that's a whole model, not a feature, that you can just call and just say, throw it an image, and it throws back some sort of structured output. So I don't know. I draw that parallel. Does that make sense to you? Do you think this is how it will help data scientists and machine learning engineers be more productive, as in they can just pick and choose things off the shelf like you can with APIs, or is it just not that simple?
No, I think it's a reasonable. I think that's a reasonable mental model for how data science becomes more fun to do. As you said, you pluck your features, you grab your pre-trained models. You've got things like TF Hub, and I think there's a PyTorch equivalent, and I'm forgetting off the top of my head what maybe it's called PyTorch Hub. You've got all the Hugging Face transformers. Like already, you're starting to see this starting to happen, and it's actually interesting. I was reflecting as you were talking about, what's software engineering is modularized. This is the direction data science is going. It's interesting to think about the other. One of the other big legs of the technology store, which is design, which is also going in this way. With Kaggle has done a big migration to material design, and so we have this big library of components, so that we don't have 20 different ways that a button looks, but we have a button. It's already coded up as a material component, so we can just, it's been designed and coded, so we can just stick the button in, and it makes, so it just seems to be the direction. The direction that a lot of pieces of the technology stack are going. And so, it seems like a logical direction for data science, machine learning as well.
Yeah, it's really amazing how in software, you're able to, and obviously I'm oversimplifying things, pick and choose things off the shelf. And in design, as you said, you can pick and choose different buttons and different banners and colors and everything else off the shelf with Figma or Canva or whatever else. And then in data science, we're trying to get there as well. We're trying to get to that point where people can just like quickly assemble things. And, a word that doesn't exist that we could use here is modularize things. So going back to deployment for a sec, and then we'll get into some stuff about data sets. You get to talk to a lot of companies, big companies and small companies. You did when you were at Kaggle because, they're in the community and you interacted with them, whether they wanted to run competitions or just to get to know the community. And you do at Google too. When you think about going back again to the beginning, when you think about the individual data scientist, what is the biggest bottleneck for them into getting a model off their machine and onto a bigger computer so that someone else can use it, access it 24/7?
Are you talking about productionizing a model, or are you talking
Yeah,
about somebody else
exactly.
being able to edit a? Yeah, I
No,
think it's what I said.
getting it into production so someone else
Yeah,
can use it. Putting it into the
yeah.
cloud, to put it in simple terms.
Yeah, I think it's the two things I mentioned strike me as the largest pain. Actually, there's a third as well, but the two biggest pain points, or two of the big pain points, are what I said: the getting the features into a production grade setting, and then having the model um, be deployed as something that is low latency enough that it's a good end user experience. The final piece, by the way, which is a really important one, is also model monitoring. Right, it's all good and well to it's kind of scary with machine learning because models drift over time, right? You might have the composite change in the composition of your customer base, for instance, or you have a global pandemic, or something very drastic changes, and your model, it's software engineering. You can write tests, and it's a deterministic system, and you can test that when um, you throw this into a function, this is the output, right? Machine learning is somewhat scary to have in production because it's not quite a black box, but it's also not a deterministic system, right? Where
Oh, that's
um, and they're often quite complex systems, and so having really good monitoring in place to see when the distribution of features going into a model that's been deployed, when the features start to drift, or for whatever reason, when if you're doing regular retraining, when the retraining is giving you, causing big changes in the model, or the whole lot of things it could be. So that's another big gotcha with respect to getting models into production.
And does this differ for small companies and big companies? Like once you get to the big company level, is there another totally different quality of problem that they're facing?
I think, I mean, obviously the higher volume, particularly historically very high volume, very low latency models you just had to be you had to be very conscious of how heavy the models were. Um, I think there's a lot of good technology being developed now by places like Google, being able to train larger models and have them execute pretty low latency. The other issue with depending on the industry, that's another way to cut this. Some industries are heavily regulated, so I know to the extent that Kaggle's worked in insurance or financial services. Financial services has the Fair Credit Reporting Act, and so if you're building a credit scoring model, not only can the model not discriminate, use features like gender or race or things like that, but the effect of the model, um, uh, the model, it's not just what you've put in, but you can't have variables that are proxies for those things. And is zip code a proxy for race, for instance? In some cases, it actually might be, and so that's often a big challenge. And then for insurance, regulation is on a state-by-state basis, and so you have to get your a new algorithm approved. It gets approved as a pricing matrix, and so making changes to models is really hard because you have to go around to 50 plus state regulators. So there's a lot of challenges on an industry by industry basis with respect to deploying models that limit how often they're refreshed, and what sort of things are done. What is how the how the model is trained and how it's used.
So let's move over to data sets. What's the state of data sets today on Kaggle? How many? Who's using them? What are some sort of headline numbers that give us a flavor for what's available there?
Yeah, I mean, for those who aren't familiar with Kaggle, we have three main components. We have machine learning competitions, which we're most famous for. We have the hosted notebook product, which I've spoken about already. And then third component, which is actually the fastest growing part of Kaggle, is we have a datasets platform. And so the way to think about this is it's almost like what YouTube is for videos, we have for datasets. Anyone can upload any dataset to Kaggle. We have over 50,000 publicly shared datasets. And it's really nice. One nice trend we're starting to see is people are using us to keep very high quality, always updating datasets available to the community. So we have really nice set of COVID-19 data sets, ranging from the obvious Johns Hopkins University data set on cases and recoveries and fatalities by city. Then people do cool things, like they'll take that data set and they'll join. There's been a question around what is the impact on weather on transmission, for instance. So when weather is warmer, does it slow transmission? Humidity is said to have an impact on transmission as well. And so it's really cool. You can somebody has taken. We had a very detailed weather data, global weather data set. We have the Johns Hopkins University COVID data set, and somebody joined the two together, matching every city in the Johns Hopkins University data set to the nearest weather station. So it's not just that we have these individual data sets, but people are starting to do really cool things. And so if you're a researcher and you want to write a paper on the link between cases and fatalities and weather, like sitting on Kaggle right now is a beautiful data set for you to grab. That's continually, the code is there that continually updates it. So there's some really nice stuff that you see starting to happen with data sets in our community. Pulling back to machine learning more generally, I think it's data sets is still one of the challenging pieces. But I like the joke that 80% of data science is cleaning the data and 20% is complaining about cleaning the data, and it sort of rings right to me. You have it's just like a very it's probably, to the extent that there's toil involved in data science, and there is, it's probably the place where there is still the most toil. Also the place where it's least obvious what sort of tooling would be helpful and generalizable.
Yeah, I mean, so I'm sort of wondering, as you say this, with so many data sets on Kaggle, where else do people go? Like, what are some other places people can go to get data just to play around with if they're doing a data science course at university or whatever else, just to practice these methods?
I mean, the idea that there's a single place to go for data sets where it's something that I believe should exist in the world, and to the extent that it exists, Kaggle's probably further ahead than anywhere else, and we're not very far towards that goal. There is Google has a data set search, which is a nice resource as well, and so that draws on when you search on Google's data set search, you search Kaggle, but you also search basically anybody who is using the rideschema.org semantics. So that's a place you can go. There's obviously general Google search, but there's if you want government data sets, you go to the state or federal government. Kaggle is running after this problem, trying to be the one place you go to find data sets. And so if you were going to search a single place, actually I'd probably do Google's data set search ahead of us, but good chance you'll end up on our website if you do make that search.
Right. And many governments, local, municipal, federal, sort of getting involved in posting data sets here, or are people just reposting what governments have?
People are reposting. We have not. There's a company called Socrata that, and then there's an open source project called CCAN, and those really have been the dominant places where government. In Europe, I think it's mostly CCAN, and in the US, a lot of local governments are using Socrata. And so that's, but the thing with Socrata is every state government has a whitelisted, Socrata instance, right? So it's not like you can go to the Socrata website. In fact, let's say I'm 80% sure this is right, and someone can correct me if I have this wrong, but I'm fairly certain you can't go to the Socrata website and search all the state, like everyone has their own instance.
Yeah.
So it's more of a software as a service.
Speaking of corrections, please do start throwing questions, comments, etc., into the chat. There's a feature here in that. We're going to go through them pretty soon, actually, in a couple of minutes, about 5 minutes. So, and as people prepare data sets for competitions, so obviously a big part of Kaggle is competitions, or was and still is part of Kaggle. And that is a big company has a problem they think can be solved using some cool stuff that the community can come up with. So they put a data set out there. So, in helping those companies put these data sets out there for competitions, you've probably come across a lot of data prep issues in general. And some of those data prep issues, especially for competitions that might involve supervised learning as a solution, there's a lot of labeling of data to do. So that is cleaning it up, tagging it, etc., so people can start using the tags to predict certain things. And what do big companies sort of do when they need to label a huge amount of data today? Um, are they doing this internally? Are they contracting it out? Who are they contracting to? What's the sort of state of play there for a large corporate that needs to label a lot of data?
Yeah, I mean, there's a mix. There's companies like Google that have built their own infrastructure for it. There are, and Tesla is doing that as well. And just as a mild aside, one of the talks that I think is most interesting on data labeling is by Andre Karpathy, who runs AI at Tesla, and the talk is called Software 2.0, and I think he paints a very compelling partial vision around what machine learning tooling should look like. He makes the case that whereas with software 1.0, I mean conventional software engineering, it's IDEs and debuggers and profilers are kind of the key pieces that help a software engineer do good work. The argument he makes is that for software 2.0, actually it's all the things around managing labeled data and the labeling tools that matter most for the performance of a model. So as an example, if your model, seeing where your model is systematically underperforming, if you are piping more of that kind of data, if you're trying to do, I don't know, recognize stop signs, for instance, and your model is consistently missing stop signs, getting more data that with stop signs in it is one thing you can do to improve the quality of your model. That's it's known as active learning. So that sort of stuff, I think, is really well, what Andre talks about is very, very exciting from a data labeling, the vision for data labeling perspective. Pulling back, I think that market is fairly fragmented. I think a lot of the autonomous vehicle companies use scale. But then you've got Figure Eight, and you've got Labelbox, and you've got actually there's a cool new technology out of Stanford called Snorkel, which is an open source. It takes a bit of a different approach where you use heuristics to inform your labels. So that's a promising new angle. There's the data labeling is crucial. There's a lot of options out there, and I think it's
Hasn't
not sort of
hasn't settled on anyone.
Hasn't settled yet. Yeah.
Okay. So let's talk quickly about one more thing before we go to questions. You've mentioned throughout, so whether it's about notebooks, whether it's about development and monitoring, and then whether it's about labeling, you just mentioned, Google's built their own internal thing for labeling. Obviously, you can't talk about what Google's got available to its own developers, but what are some, just really quickly, what are some Google Cloud products that came out recently that people should know about? They might have missed the announcement or whatever else, but what's some really cool stuff that has come out recently?
Yeah, I mean, one of the perhaps the thing I'm most excited about that's come out of Google recently is TP. Sorry, not recently, but is recently maturing as TPUs. So we had the jump from CPUs to GPUs has completely transformed machine learning, and TPUs GPUs have real strengths on certain workloads, and TPUs have real strengths on certain workloads. And I think that some of the challenges with TPUs historically is they have been quite hard to use, and usability has really improved. There was the launch of TensorFlow 2.1. which had really nice, uses the Keras APIs to train TPUs, which to train on TPUs rather, and it makes it trivial to switch between TPUs and GPUs. Solves a lot of the challenges people had from a usability perspective. And now PyTorch, the PyTorch XLA, I think, is now GA. So this is a flavor of PyTorch that runs on TPUs. And so I think some of the areas where TPUs shine are areas where historically where I think it is possible to see really strong model performance improvements. And probably the biggest are TPUs are very, very good for very large scale models, and they're also particularly good for very large recommender systems and ranking systems. So that's an area I'm excited about. And then the other one is, this is not a single product, but the idea that there are, and it probably applies to all the clouds, the idea that that a lot of the toil around doing data science is starting to get easier and easier. Make some of the things I mentioned earlier, like the various investments in feature stores and easy ways to push models into production, make data science a lot less, I guess, tedious to do, and makes data scientists much more productive. And so it's just like a lot of little paper guts that are getting cleaned up by some of the cloud providers, as well as a lot of startups running at this as well.
Okay, let's go to a question. I think we've got a question waiting from Nathan. And when he jumps on, we'll let him ask that question. There we go.
Hey, good to see you guys. Yeah, so I'm Nathan, joining in from Portugal, actually. So I've been a big fan of Kaggle over the years, and one of the things I was really curious to get your take on was essentially why, I guess, like Kaggle was held back in its like potential that I saw to basically be like a problem solving as a service provider. Because like you were outsourcing all these really neat problems from enterprises, but I sort of feel like you could have probably gone a bit further and maybe systematized that offering to many more problems that were out there. And like you've seen kind of mini Kaggles, as it were, in finance, like with Numerize. So if you could cast that across lots of different industries, why didn't you do that?
Yeah, I guess a bunch of different directions. Kaggle experimented over the years with a lot of different directions. Our initial thesis was that there would be 3 ways of getting data science problem solved. One is you have an internal team. The second is you have a consultant. The third is Kaggle offers like a crowdsourcing style offering. And hard to know exactly what the breakup would be between the 3, but there'd be some share would be done by internal teams, some share by consultants, some share by a crowdsourcing mechanism. Few things kind of made that challenging. One is like we would work with an insurance company, for instance, and we'd work on a claims prediction problem, and then they would have the recipe for how to solve the claims prediction problem, and they'd sort of take the recipe and roll it out across all their models, right? And then we're sort of useless on that problem. We sort of don't get more renewal business. The other thing is that taking models out of Kaggle was always, it's kind of what I was talking about before, it's hard to productionize them, right? And so there's a tremendous amount of work if you think of an end-to-end machine learning problem where some fraction of the solution, but there's a heck of a lot of work before a Kaggle competition in terms of framing the problem, and then after it. So let's say we're 30% of the work. And I think what we were most useful for in practice was, companies had tried a problem internally, they'd done as well as they could. They wanted to see, how well it was able to do, how well the outside world could do on the problem, and what the methods were. So that really was the strongest use case. And there's just like a limit to how far you can scale that use case. Then the other thing we toyed a little bit with was this idea of like a consulting marketplace, this idea where we could match companies with individuals in our community. And I think there's a lot of challenges there as well, particularly for larger companies, like giving access to people from our community to data sets was certainly a big blocker. Also, I think very often for more open-ended problems, having really good domain context is helpful. And then a lot of those in it. To do well as a consultant, I think you need a combination of very strong project management skills as well as strong machine learning. And doing well on Kaggle definitely demonstrates strong machine learning skills, but not necessarily project management skills. So to the extent that we tried different permutations of scaling up the idea of companies posing problems and our community solving them, those are some of the blockers that we experienced, and some of the reasons that rather than digging in deeper there and trying to really scale that, we went broader to doing things like Kaggle notebooks and data sets.
Nathan,
So I hope that answers the question.
Up to you.
Yeah, no, thanks a lot for that. I think you could probably look at all the topics that you guys discussed over the last 45 minutes, and actually, if you would probably try this whole adventure again, it would make your life a lot easier. Like things like synthetic data, like easier pipelines, stuff like that. So maybe we'll find a Kaggle 2.0 somewhere.
Should be Kaggle.
Yeah, or it could be Kaggle. Mark Dowd, we've got you on the line, and please go ahead and ask the question.
Thanks, Ash.
I'm pretty happy with Kaggle 1.0. I'm joking. Sorry, Mark.
Work at New York MTA, etc. You talked about active learning. In transit, we don't do a whole lot of active learning. We pretty much provide service. And with COVID, it's kind of exposed a lot of the vulnerabilities that we have and our inability to react to those vulnerabilities. I was intrigued by, whether or not there's opportunity. Look, we don't have any data scientists in our agency. We have 77,000 people working for us. How do we leverage some of the communities that are out there or the work that you're doing to try to figure out a way to be more responsive to COVID challenges specifically, but more importantly, how do we, the data sets and the information, it's not that we don't have smart people in our agency, it's just that we're not programmed that way. And if you had any suggestions on how, it's not just us, by the way, it's not just MTA.
Totally, yeah.
And we are, we have a very strong vulnerability right now, right? And how do we use either your approach on data or the machine learning to get us in where we can be more reactive?
Yeah, I don't think Kaggle is a good fit, to be honest. And I think we're a better fit for, you have a data science team already, and we have a bunch of things that are useful as a way to make them more productive. I think that, and I think it's kind of hard to tap the community while they're outside the walls of the MTA. My guidance on this always is, start with a very small team. And start with small wins, right? And have the team, small win, bigger win. Start to just build up the muscle, right? And it's the sort of thing that it's not a quick fix, but maybe you want to start off with, I don't know, better demand forecasting or something. And there's a way to, I don't know, I'm just, yeah.
No, it's exactly, even just getting into a demand mentality, right? But okay, fair enough. Look, the problem, as you know, with public sector is you get that muscle memory and the muscle leaves.
Yeah, sure. Although if, people churn out. I think public sector, private sector. You look at the Bay Area, and there's always a shiny thing. But if you can get a bit of a critical mass of a team, 3 or 4, so you lose one, but then you have 2 who have learned from the one, and then one of those, and you sort of,
right.
Yeah, exactly. I think the term they use is bus factor. Make sure there's not a bus factor of one being, if that person leaves, all the knowledge leaves. Yeah.
Okay. We do have one more question in the Q&A, but I don't actually think that that's a good question because it might involve talking about too much stuff that's internal to Google. So do appreciate it, but I don't think it's a question that we can probably answer in a relatively public forum like this. If there are any other questions, please shoot them through. I'll just ask one more question while we wait to see if we get any more. And you built a community from the ground up, and I guess as you sort of went through that process of building a community, it's something that you, at least when we were working together, like you always knew that this was a very valuable, important community, but it was sometimes hard for investors to see that ahead of the more obvious things that tell you a business is working or not, which is we've got money coming in the door. And so for those founders out there building sort of community type businesses, community led businesses like developer communities and whatnot, what do you think are some important metrics that will tell them they're building something really valuable? And this just sort of takes you back to, when did you know that this community you were putting together was a really valuable community that was doing great things and would go on to do important work? And if you sort of were running that community, you could be part of that. But yeah, what was it? What did you see early on, and what do you think are important metrics for building a community or developer led?
I don't know. I guess what one of the reasons, Kaggle had lots of ups and downs, and one reason that I always felt very motivated to push through the downs is that I felt like we had built something special. I don't know that commercially valuable was the motive, was like the thing that was my driving force through a lot of Kaggle. But I'd gotten to know a lot of the community. Kaggle was a big part of their lives, had made a big difference. And I think probably I had the somewhat naive assumption, I no longer believe this, I guess as you see more, I used to, I think when I first started Kaggle, I used to think, you create value in the world and you can capture some of it. It's actually, there are a lot of open source software is a great example of this. A lot of cases, open source projects create a tremendous amount of value, and in some cases, they monetize nicely and turn into good companies. In other cases, they don't. I think that now it is easier for certain types of businesses, particularly open source businesses. There's a lot of templates to follow. You've got open core, you've got support models, like
models, and
and so I think there's probably more prior art now to give an idea for how to monetize, depending on what the type of community is. But Kaggle's community is somewhat, it's different to a lot of other communities. I look at it as more analogous to GitHub and Stack Overflow than an open source community. And I think if you look at communities like Kaggle, like GitHub, like Stack Overflow, monetizing them is not like a single. I don't know that there's like a single template that each of us have followed in order to monetize effectively. And I think also the other thing is we've monetized. Each of us have monetized more or less with more or less success. So I think our type of community is a little anomalous. As far as community health is concerned, one dynamic we certainly see with Kaggle, which is a dynamic we're really trying to work hard on, is I think a lot of people pass through Kaggle as a result, through their machine learning journeys. But one thing that Stack Overflow and GitHub do, have nailed really nicely is there's probably not a day or week that goes by that a software engineer is not on GitHub and or Stack Overflow. And I think that with Kaggle, there's a lot of reasons to come back on a daily and weekly basis. Like if you're starting a project, we have an example notebook that will show you how others have tackled that project. If you're looking for a data set, we have a large data set repository. But we are less of a daily habit for data scientists than I think Stack Overflow and GitHub. And so to give you, maybe rather than answering, what metrics tell you about health, the metric that we care most about is the ratio of monthly active users to the size of our user base. That's one we're really focused on at the moment.
Okay, yeah, but in the early days, it was about knowing them. That's a good one to end on. Well, thank you very much, Anth, and thank you very much to everyone for your time. We will be having another one of these um, in about a month or so. We'll announce that in the next newsletter we send out. There's a survey link and a sign up link so that you don't miss that. But yes, a survey link in there to tell us what you'd like to see more and less of in the next one. And thank you very much again for your time. And thank you, Anth, for the work that you do and for sharing some of it with us today.
Thanks for having me. Nice to meet everyone.
See you guys.